I'd like to start off by asking you to remember what happened almost a year ago, the Deepwater Horizon incident in the Gulf of Mexico. Some of you may recall the images as the oil rig sank into the Gulf of Mexico and the ensuing oil leak that happened. You may also recall the remotely operated vehicles that were used to fix the problem, to seal the pipeline, and ultimately to save the day. Now, as good as those vehicles are, they have one major limitation. They're actually tied to the motherships up on the surface via communication links. So the human operator on the surface drives those ROVs. However, that communication link, that tether, then limits the range of operations that the vehicle can move through the water. Today, I'd like to talk to you about a different kind of vehicle. It's known as an autonomous underwater vehicle. It's a project that we've been working on at Flinders. Okay. We live in a country that's surrounded by sea. We've got one of the largest coastlines in the world. Our marine resources are probably our most significant asset in this country. They offer us extremely good opportunities for oil and gas and mineral exploration. They also offer us opportunities to feed our growing population. It's therefore important for us to be able to make sure that we protect our marine environment and that we are capable of defending the environment, our coastal resources, and our borders. Now, given the scale and the depth of the oceans around us, it's clearly impossible and not sustainable to do this using manned surface and submarine vehicles. We therefore have to look at alternative methods, and in particular the proliferation of robotic vehicles to be able to do these jobs for us. These are some examples of some autonomous vehicles that are out there in the market today. They're all characteristic in one sense. Firstly, these vehicles are used by the defense, the oil and gas sector, and by the scientific community for their various types of missions. But all these vehicles, in fact, nearly all the vehicles out in the market today, actually started life as a university project and then got spun off and adopted by industry, particularly the defense industry and the oil and gas industry. In the defense industry in particular, they're interested in using the vehicles for three main roles. One of them is mine countermeasures, so looking for mines on the seabed as well as on the bottom of ships. Doing bathymetry operations, being able to get 3D terrain of the seabed, and looking at oceanography, particularly ahead of a submarine. In the case of mine countermeasures, a vehicle would fly over the seabed, scan the seabed with a high-resolution sonar, look for potential objects such as mines, and then, if it identifies mines, use a low-cost, single-shot disposable AUV as the one on the right over there. That's an Archer fish developed by British Aerospace to go ahead and destroy the mine. The oil and gas sector actually has some interesting applications of its own. They've been using vehicles for a while as well. Firstly, the oil and gas sector is moving further out to sea in terms of its range of operations. And in the case of Australia, out to sea means into deeper waters, going down to depths of 5,000 meters. That's where the latest releases for the oil and gas sector are at the moment. And in order to prevent risks, they're moving everything, the wellheads, the distribution networks, the pipelines, all down on the seabed as shown in the bottom right image over there. Now that puts them away from risk from surface effects, but unfortunately also puts them far away from access by manned vehicles. So the oil and gas sector have been looking at the use of these vehicles, autonomous underwater vehicles, to do survey operations, to do inspection operations, and ultimately even to look at doing intervention operations where the vehicle can interact and do operations on the infrastructure. The image up at the top shows a typical application where an AUV is scanning a pipeline, looking for potential hazards. The pipeline may actually move because of movement of the slope in this case, or can get covered by sand. We've got a problem in Australia. Although there are a number of AUV manufacturers around the world, there's about 15 commercial manufacturers. There are none in Australia. They're all based in the US, the UK, and Europe. So that means anybody over here who wants to use an AUV has to pay for it. Firstly, the vehicles themselves are quite expensive. They cost anywhere between $600,000 and several $1 million to buy. Okay, so you've bought your AUV. Like any car, you then have to maintain it. So you've got to send it back for maintenance, except you've got to send it back overseas. If you want to modify anything on the vehicle, the manufacturer restricts the operation, any modifications that you make, so you've got to send it back to the manufacturer to modify the vehicle or repair it. So that comes to the second option, where you've got the option of leasing the vehicle, and that's not a cheap option either, because it costs a minimum of about $20,000 a day just to lease the vehicle. Then you have to pay for the ship time and the specialist crew to look after the AUV. So all these factors combined make it difficult for local operators to use AUVs, and Australia is lagging way behind other countries in terms of using these vehicles. Of the 400 or so AUVs that are available around the world, there's only about 4 of them in Australia, and most of those are not commercially available. They're used by the military. Then there are additional problems. The vehicles themselves, the ones I showed you and others, they're all very simple in terms of their level of autonomy. So they're very good at doing exactly what you tell them. So provided you give them a good mission plan up in advance and you take into account all possible factors, they'll do exactly what they're told. They're not reactive. So if they see something that may be interesting to the human operator up on the surface, they can't take advantage of that. They can't go ahead and follow that new interesting object and change their mission. So they're very simplistic. The second thing as well is that the manufacturer is interested in protecting their IP. So they've logged the system architectures. So I can't come along and say, okay, I'm developing a new navigation system and put that onto one of their vehicles. They won't allow it. Same thing for any operator over here working on sonar systems or new control systems or towed arrays or whatever. It's very difficult for them to modify the vehicles. And lastly, the lack of a local AUV industry combined with the fixed system architecture makes it very difficult for local industry to contribute new technology to the development of AUV technology. It's a very closed market, and one, unfortunately, that favors the overseas manufacturers. The solution, therefore, seems to be to have our own AUV industry here in Australia. It would provide us with 3 advantages. Firstly, to the end user, it would allow easier access and more economical access to AUVs, technology, and to expertise to use the AUVs. It would allow local industry the opportunity to get engaged in developing sensors and systems for AUVs, something that they're not capable of doing at the moment because they haven't got ready access to the vehicles. And thirdly, it would allow increased revenue earning back to our economy by value-added services to the offshore oil and gas sector, the export sector, which is extremely lucrative. So if we include things like vehicle maintenance, vehicle construction, training of operators, and leasing of vehicles, that's a highly lucrative area. This is a vehicle that we've been working on at Flinders for a number of years. We're actually working on it in partnership with the Australian Maritime College down in Tasmania, and more recently with Pacific Marine Batteries as well. The vehicle is a modular structure, and that has a number of advantages. Firstly, it can accommodate different payload sections. So if somebody comes along and says they want their own sensor suite onto it, they can simply change the payload to suit their sensor suite. If they want thrusters on it, lateral thrusters to allow the vehicle to hover, say around the mine or around the pipeline, again, we can do that quite easily. The vehicle, as standard, carries high-resolution sonar systems, both forward-looking and side-scan bathymetry sonar, so that we can get a nice 3D image of the terrain. We're currently in the process of constructing this vehicle together with our partners, and we're working with a number of manufacturers here in Adelaide to look at doing that. As I said, the vehicle is modular. It uses a unique ring locking mechanism to allow us to disassemble the vehicle and put it together. So those red lines there are the rings. If we spin them around, we can unlock the components, the modules, put in a new payload section very quickly, in effect change the mission capability. Put in a new battery without having to recharge the vehicle as a whole, just change the battery compartment. And ultimately even transport the vehicle becomes much easier because you now can put into small cases and it becomes easier to transport rather than one large vehicle. By the way, that vehicle is about anywhere between 3 meters up to 4 meters in length, depending on how many units we put in there. Okay. These are some of the results from our algorithms that we've been working on for navigation and control and guidance systems. I don't have much time to talk about this at the moment, but I'll happily talk about those later. But some of the results for the navigation system in particular are pretty good. Okay, so I've talked about the establishment of an AUV industry here in Australia. To get this kick-started, we need to establish an AUV Research and Development Center, which will be a collaboration between industry and academia. We need funding to be able to support the postdocs working on the projects, to work with industry, the equipment and the construction costs. We aim to get this through industry collaborative grants, through academic grants, and through government industry startup grants. We've already started the ball rolling by getting our collaborations going with the Australian Maritime College, the University of Adelaide, and Pacific Marine Batteries, but we're looking for more companies, particularly companies that have needs to use these kind of vehicles or to deploy sensors on these vehicles, to build sensors on them. The AUV industry is growing very fast. It's estimated to grow, just the value of the vehicles themselves is estimated to reach about $2 billion over the next 5 years. It will increase even more if one includes the value-added services of maintenance, leasing, training, and construction that the industry can provide. So it's a worthwhile opportunity to get involved in this and to actually develop an industry here in Australia right now. Thank you for your time.